encapsulation of fields such as nanotechnology, quantum computing, 3D printing, mobile networks, artificial intelligence, and neuromorphic technologies create realities that were unknown and unthinkable, transforming every industry for the better. All of these new paradigms will affect the very essence of the human experience and the human condition, referred to as cyber-physical systems, which is marked by emergent technology breakthroughs in a number of fields, including robotics, artificial intelligence, nanotechnology, biotechnology, Internet of Things, deep learning in artificial intelligence. Each level learns to transform its input data into a more abstract representation. For instance, in an image recognition application, the raw input may be a matrix of pixels. Artificial neural networks. Neural networks feed forward back propagation network for supervised or unsupervised learning. Neural networks learn by example. They have been used in applications ranging from autonomous vehicle control to facial recognition. Artificial neural network is a computing model inspired by nature. It is a methodology mimic at a certain level the way the brain reacts to various inputs. When a neuron is excited by a stimulus and becomes active, it sends a small charge along this network, which in turn causes other networks in the network to become active. Deep learning in applied neuroscience, artificial intelligence, neural network, algorithms. The basic strategy in implementing a neural network as a high-level program is to establish a framework of data arrays to hold the weights and to track accumulating totals as signals are fed forward and errors are fed backwards through the network. A sequence of nested for loops iterates through these arrays, making the various calculations required as the backpropagation algorithm is executed. Software algorithm and process initialize the arrays. The weights are set to random numbers. Begin a large loop that runs the system through a complete set of training data. Artificial intelligence, reconfigurable robotic systems are autonomous kinematic machines with variable morphology. Beyond conventional actuation, sensing and control typically found in fixed morphology robotic systems. These robots are also able to change their own shape by rearranging the connectivity of their parts in order to adapt to new circumstances and to perform new tasks. For an artificial intelligence autonomous stochastic robotic system to accomplish tasks when the outcome of actions is non-deterministic, it is necessary to apply error correction and error detection. In this segment, I will introduce a general framework that illustrates the implementation of inertial measurement system for artificial intelligence robotics applications.
Here is a demonstration of an efficient orientation filter able to provide an estimate of the inertial measurement unit orientation relative to the Earth through the fusion of tri-axis gyroscopes and tri-axis accelerometer.
Kalman filter allow the use of mathematical models to gain an estimate of a system state. By using Kalman algorithms, noisy accelerometers, gyros, and magnetometer data can be combined to obtain an accurate representation of orientation and position. This is an excellent use for robotic systems applications.
The algorithm is computationally driven based on Kalman solutions used in this current application. The objective is to illustrate a demo in this video using machine vision technology in combination with the camera and artificial intelligence software algorithms to achieve image recognition. Image recognition, as it relates to machine vision, is the ability of software algorithms to identify objects, places, people, writing, and actions in images. Convolutional neural network takes advantage of the fact that in any given image, proximity is strongly correlated with similarity. That is, two pixels that are near one another in a given image are more likely to be related than two pixels that are further apart. In a typical neural network, every pixel gets connected to every single neuron. In this case, the added computational load actually makes the network less rather than more accurate. Image recognition convolutional neural network algorithms can function by use of comparative 3D models, appearances from different angles, using edge detection. Image recognition algorithms are often trained on millions of pre-labeled pictures with guided system learning. Pooling layer, which takes several dimensional arrays and applies a downsampling function alongside the special dimensions. The result is a pooling array containing only those parts of the image that are more important while discarding the rest, which both minimizes the computations that are needed to do while also avoiding the problem of overfitting. The neuron transfer. Once a neuron is activated, the need to transfer the activation to see what the neuron output actually is. Different transfer functions can be used. It is traditionally to use the sigmoid activation function, but you can also use hyperbolic tangent function to transfer outputs. The sigmoid activation function looks like an S shape. It's also called the logistic function. It can take any input value and produce a number between 0 and 1 on the S curve. It is also a function in which you can easily calculate the derivative, which is the slope.